So question 2 is about topic 2, capacitors and dielectric. So we have a 1.5 microcoulomb fully charged A-filled Pyloroplate capacitors. So I visualize it. So this is the Pyloroplate capacitor. A-filled means in between the two plates there is the A gap. So this capacitor is fully charged with a charge of 1.5 microcoulombs. So the area of the Pyloroplate capacitor is 2.5 meters squared, and there is a correction for these questions. And the plate separations, the separation between the two Pyloroplates, I denote by D, is 3 millimeters. So calculate the charge on the capacitor 0.5 millisecond after being connected in series to a 250 kilo ohm resistor. So we connect these fully charged capacitors with a resistor, whereby the value of resistance is 250 kilo ohm. So what are going to happen when we connect it to a 250 kilo ohm resistor? So these fully charged capacitor are going to have the discharging process. So it means that this fully charged capacitor will be discharged through the resistor. So the question asks us to find the charge on the capacitors. We want to find the charge on the capacitors after time 0.5 millisecond times 10 negative 3 seconds. So we want to find how much is the charge left in the capacitor after 0.5 milliseconds. So this is a discharging process. So in order to find the final charge after time t, 0.5 milliseconds, so I identified the equations. So I'm going to use equation 15. Equation 15. So I'm going to have Q equal to Q naught, the initial charge in the capacitor, multiplied with exponent to the power of negative t over RC. So I'm going to find the final charge when the time is 0.5 millisecond. So the Q naught, the initial charge in the capacitor, is 1.5 microcoulomb, and then the R is 250 kilo ohm. But then the capacitance of the capacitors is unknown. So in order to solve this question, I have to calculate the capacitance of the capacitor first. So how I'm going to find the capacitance of the capacitors? So since this is a Pyloroplate A-filled capacitors, so I'm going to find the capacitance using equation 18. Equation 18. The A-filled capacitor. So I have C equal to epsilon naught A over D. So the epsilon naught is the permittivity constant. You can get the value from the list of constant is 8.85 to the power of negative 12. The area of the plates of the capacitors is 2.5 meters squared divided by the separation between the plate is 3 millimeters. So I'll get the capacitance is 7.38 to the power of negative 9 farads. So after I get the capacitance, then only I put it back to these equations. So the initial charge in the capacitor is 1.5 microcoulomb, exponent to the power of negative. The time that I need to determine the final charge is 0.5 millisecond. So times 3 times negative 3, over the value of resistance is 250 kilo ohm times 10 power of 3, and then the capacitance is 7.38 to the power of negative 9. Okay, then we do our calculations. We will get the charge on the capacitor after 0.5 millisecond. The value will be around 1.14 to the power of negative 6 coulomb. Then we solve our question.